Ba-da-ba-da. Yeah, I mean, I built the studio space, so might as well use it. Do I have anything planned or scripted? No. Okay, today we'll be taking a look at this Emulator II synthesizer by Emu Systems Inc. And this comes from the broken synthesizer pile in the back part of my basement. Now, for those that don't know much about the Emulator II, it's a sampling synthesizer from the mid-1980s. It was used by a lot of bands like New Order and Depeche Mode and other synth-pop acts of the time. Now, the reason this has left the junk pile is that I have a recording session set up with my band next week, and I want to try using the Emulator II on a couple tracks. I mean, it's in a semi-working state. It's got some pretty serious bugs that's preventing me from just recording it as is. So let's take some time and list the issues up on the chalkboard here. First of all, it's got a bad voice channel. I'm pretty sure it's channel 7. It's a 8-voice polysynth, and when you get up to that 7th note, it sounds off. Now, I think it's one of the SSM filter chips that's gone bad, and that's a really interesting discussion on the architecture of this synthesizer. It's set up like an 8-voice polyphonic analog synthesizer, like a Prophet 8T or a Jupiter 8, but instead of analog oscillators, it has digital samples. Which for me is kind of like a best of both worlds scenario, because you start out with these like nice crunchy digital samples in place of a VCO, and then you follow it up with a VCF and VCA. But yeah, we can talk about the architecture of the analog signal path later. Our next problem is this thing has flaky floppy drives. Now, coming stock from the factory, the Emulator II had black floppy drives instead of these beige ones right here. So it looks like they've been replaced in the past. It seems like there might be a loose cable in here, because when you move the emulator, well, sometimes the floppy drives work and sometimes they don't. And it's not like a disk read error or anything. It's like sometimes when you switch it on, it sees floppy drives and other times it doesn't. Now, it's super important I get these floppy drives working, because the Emulator II doesn't have any built-in samples. It loads everything off of floppy disk. And really, I don't need 2 floppy drives in this thing, so it might be pretty cool to replace one of them with one of those Gotek drives that uses the USB sticks. Yeah, that would definitely bring this thing into the 21st century. This one's gonna be easy, I got replacement keys. Ooh, and the screen. The Emulator II uses a pretty standard 16:2 LCD. Except for the fact that it's not standard anymore. Now, what I mean by that is the data and address lines on the LCD are pretty standard. They have a very similar pinout. Here, one sec. This LCD is kind of like a jelly bean part at this point. It's one of these, what, like Sharp or Hitachi, what was it, like a 1602 display? You know, the kind with all the little pin headers in the top row like that. So the actual pinout of the LCD controller that puts all the characters onto the screen is pretty much the same since it's been in the 1980s. With the exception of the backlight. Emu decided to use a pretty new backlight technology of the time. It's an electroluminescent backlight that requires a high voltage transformer circuit inside the synth, and all that's gone to crap. So while you can read the LCD screen pretty clearly in direct light, or sunlight, or studio lights, but in any other case, you can't make out anything on the screen. So we'll be replacing the LCD screen here with another LCD screen, just with an LED backlight. General cleaning, that's a given. And finally, I heard you could hook this thing up to a computer. So we might have to be giving that a try, if we can find the right software. So without further ado, let's move this hunk of junk over to the bench. It's so heavy. And there we go. I think this is the largest synth we've had on the channel so far. You know, when I first built these, I was thinking about making this one about 6 to 8 inches deeper. Kinda wish I had. Let's power this thing up. You can hear this weird startup noise. I think the noise it makes when it boots up is some sort of self-test. Yeah, let's load a sample disk in here. Try another disk here for boot. Hey, there we go. This thing sounds so cool. And this one here is a phased guitar sound that I sampled into the emulator. Git bank disk 2. And it'll load that in. You know what? I think this is that dead voice. Oh, that's something else. Try rebooting. And now it just doesn't boot. And suddenly the second drive is gone. You know what? Yeah, so I think there's some sort of loose ribbon cable or something in here, because we had both drives working, then none of the drives working, and then just the first drive working. One, two, three, four, 5, 6, 7, 8. See, now only one of the voices works. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we not only have intermittent floppy drive activity, but also intermittent voices. Okay, I think it's time we open up the Emulator 2 and see what we can do about this. Ooh. Yeah, there's something loose in there. So my guess is that the machine screws that are around the perimeter are going to be holding the case on. I think these 3 here and maybe these 2 are going to hold the key bed in. And it looks like we have some sort of bracket here for the floppy drives, perhaps. Yeah, these screws are going to stay in as well. And it looks like we got 4 around back. Oh yeah, this is the fuse holder for the synth. It pops out really easily if you have the synth up like that on its back. Alright. And here we have the inside of the Emulator 2, complete with giant ribbon cable. Over here we have the Emulator 2's digital board. Now, this thing is massive, measuring at roughly 10 by 18 inches, and seems to contain just about every chip possible out of the Zilog catalog. Right off the bat, I'm seeing a Z80 serial interface, probably for MIDI, a DMA controller, a counter timer chip, 2 PIO interfaces, which is normally for 8-bit parallel data, and 2 Z80 CPUs. We've got the main ROM here, and a ROM dedicated to scanning the keyboard, which is a technique that Emu Systems invented. Okay, what else? I'm seeing some static RAM chips here and here. We've got some static RAM chips over here. Looks like 1, 2, 3, 4, 5, 6, 7, 8 times 256, 2 banks. So like 512K of sample memory. And it seems to only be half populated. That might make for a pretty cool upgrade. Looks like this might be expandable out to 1 megabyte. And we have some unpopulated sockets here, 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 and here. And no clue what goes there. We also have some ceramic chips up here, which are Intel static RAM chips. Each one of these is a grouping of 1K by 4 bits. So like 3 kilobytes? So yeah, now I'm starting to see why the Emulator 2 was so expensive. Not only do you have 2 CPUs, along with a whole bunch of LSI/VLSI logic chips, but you have like 3 different kinds of RAM, static RAM, which was pretty expensive at the time, and the cost of manufacturing this entire printed circuit board. And that's only like half the synthesizer. Now, moving on to this section, we first have our power supply right here. And I think I'm gonna unplug the top bit from the rest of the case and move that off to the side. Let's unplug this there. You got these screws. Get our floppy drive assembly out of the way. What's this? I know what that is. This is one of the weights that's supposed to be attached to one of the weighted keys. Where did you come from? Oh, it's this one up here. And actually, I think before I continue, I'm gonna go ahead and replace this key down here and fix the weight on this one up here. So with these keys, you just push down in the back and slide forward. You can see how the little plastic notch has broken off this side of the key, which is causing the spring to push the key up this way and into the keys next to it, which is why it sticks and doesn't return properly. I got my box of parts for the emulator right here. And here's our replacement key. Just gonna reuse the spring. Get it to line up with this little divot down here, if you can see that. Perfect. We'll just remove this one on the side. And I'll grab some Gorilla Glue and try to glue this back in. I don't think I'm going to do a full disassembly and cleaning of the key bed because the key bed plays pretty well and doesn't seem to be all that dirty. So we'll just leave it be for now. Now back to this grounding nut here from the power supply section. Here we go. Yeah, I just really don't want to go outside. All my nut drivers are in the tool chest in my shed. And it is gross and cold out. And here we have our output board. Looks like we have some Intel 8254 programmable interval timers. Each one of these chips is essentially a programmable oscillator with 3 outputs. And 2 of these are used in the Juno 106 for its digitally controlled oscillators. Now my guess on how the Emulator II works is it's storing 8 copies of the same sample in RAM. And it's using 8 of these 9 oscillators to control the playback speed of each sample. So when you hit a key on the keyboard, it should determine a frequency for one of the oscillators to play back at, and use that as the speed to clock out the sample from RAM. But that's just a guess, or that's how I do it. Well, I was just a bit too curious, so after taking a quick look over the emulator service manual, it appears as though the CTCs control sample and hold timing between the channel DAC outputs and the rest of the analog signal path. So yeah, that's what these analog switches seem to be doing. They're buffering this capacitor and just temporarily holding a voltage there in a sample and hold circuit. Okay, what else do we have here? And looking around the board here, we also have these AM6072 companding digital to analog converters. Looking at the schematics for just one of the synth voices here, you start out with the digital to analog converter, which is this chip over here. In this case, we're looking at synth voice 0 or channel 1 in this cluster of circuits. So yeah, our digital to analog converter feeds into this SSM 2045 chip, which is this one, closest to the back. Our 2045 seems to be our synth voicing chip, which seems to handle low-pass filtering and VCA functions. Now what's thrown me for a bit of a loop here is this synth voicing chip feeding into this AMI S3528 chip. That's this chip right here, which seems to be a programmable low-pass filter, usually used in the telecommunications industry. Now, I think this chip might just be used for anti-aliasing, because if we take a look at our control voltages coming into this section, we have our frequency control voltage for the filter going into our SSM2045, our resonance control voltage for the filter going into our SSM2045, and our amplifier control voltage, also going into the SSM2045. This little circuit here is just another part of this larger chip. So yeah, hopefully the SSM2045 in our channel that doesn't work is the culprit here, because they make modern reproductions of these chips, but not these low-pass filter telecommunication chips. Alright, now let's get to some troubleshooting here. So let's start out by applying a little bit of deoxit to all the connectors. That little heatsink popped off. We just glued it onto the 7905. Wow. That is so cursed. We will never speak of that again. Really need to get a bottle of that concentrated deoxit D100 stuff, because way too much deoxit always ends up leaving the bottle. Yeah, these look alright, but still. There we go. Alright. That smells like smoke. That's not good. Okay, cool. Got both disk drives working. That's good. I'm a big fan of this patch I made. It's just an Omni chord that I sampled in here. Okay, so I've gone through the special functions menu and disabled all the channels. So right now nothing plays. Okay, we'll activate channel 1. One voice. 2. Channel 3. 4, 5, 6, 7, and 8. Huh. You're supposed to be broken. So, hi. It appears that it works now? Man, I hate it when electronics do this. So it appears to work now, I guess? And I know you heard it. One of the channels didn't work. Maybe that short cleared something up, or deoxidating and reseating the connectors. And I was fully ready to go in and replace a voice chip. Alright, I think our course of action going forward is going to be to keep an eye out, or rather an ear out, for these voice channels to see if any start malfunctioning or we start dropping voices. If so, we can take the chips out, deoxit the sockets, reseat them, and if worst comes to worst, maybe repair a couple cracked solder joints or replace a chip further down the line. But in the meantime, I think I'd like to turn my attention to this pretty dim LCD screen right here. Alright, so here we are looking at the back of the Emulator II's control panel. By the way, this is where that bad smoky smell was coming from earlier. I'm like hoping I didn't damage anything by resting it on the metal edge of the case. I pulled this chip and checked it and it seemed fine. The 7474s are just 8-bit latches. I got a bunch of those if any of those have failed. We saw that the screen works, the potentiometer seemed to work just fine. Though I'm really hoping I haven't shorted out any of the carbon tracks on the sliders here. That's going to be costly and hard to find. Oh, and resistor packs and LEDs are a pretty easy replacement. Okay, back to the modification I have in mind. So right over here we have our LCD module. And for any of those out there who have played around with these 1602 LCD modules, you'll see some similarities. The LCD's data lines and the emulator schematics seem to be just the same as this one here. Same with the power and control lines. So the 14 lines on this LCD module are the same as the first 14 lines on this one. They only control information being written to the LCD. The only difference being the remaining 4 pins on this LCD module control the backlight. Yeah, this is one of those fancy ones with an RGB backlight. Now, on the original module, it appears they had this high voltage circuit here that drove an electroluminescent backlight, which has the disadvantage of needing to include this ghastly high voltage circuit and then no longer being TTL compliant in terms of the backlight. So I think it's in our best interest to get rid of this inverter circuit altogether. You know, worst case scenario, something bad happens to it and it damages all of the TTL components in our Emulator II. And we should replace the LCD with one that has a working backlight. In my current studio setup, the Emulator II would sit in the lower portion of a multi-tiered keyboard stand, which makes it nearly impossible to read this screen. So let's start out by removing this LCD module. Alright, you know how some people have that cool superpower or one weird trick? Well, here's mine. 9:30 seconds. Damn. See, always one off. I thought these screws were standoffs, part of the case, but it looks like they're just regular screws that are mounted on the other side of the PCB. So let's get this main board removed. Alright, and there we go. Well, that explains that burning smell. You can actually see down here at the bottom where a short happened and one of the traces went up like a fuse. Alright, I've got the left-hand control panel on the workbench, and we'll see if this short here did any damage to this slide potentiometer. And just checking against this one for comparison. I will say, it's pretty strange how the values go up and then back down, so maybe I'll have to cross-reference the schematics to see how these are wired up. I do somewhat understand what's going on here though. These pins are all one end of the potentiometer and are connected together. Same with these pins. Yeah, so these 10K potentiometers are all wired in parallel, which explains why it would be 2.5K across both terminals. And what's this? Yeah, it's part of our broken key there. Yeah, I could glue this back together and hawk it up on Reverb as slightly used. So the potentiometer seems to check out fine. So let's run some bodge wire from this point over here to this point over there. And for a job like this, I can't recommend wire wrapping wire enough. It's just thin solid core wire. I think it's about 30 gauge. Oh, wait, I'm an idiot. This point's supposed to run all the way up here, not down here. Wouldn't have done any harm, but this potentiometer still wouldn't work. There we go. Next, let's remove this inverter and cable. And here's the inverter. That's an adorable little module. I've got our old LCD module desoldered from the board now, so we should be fine to pop this one in place, right? Well, unfortunately, it looks like we've run into the problem of the dimensions not lining up. You see, our older LCD module has a much larger PCB, and the mounting holes are in different places. Plus, our new LCD module is a lot thicker than our old one. You see, the glass that contains the liquid crystals is relatively the same thickness. However, the backlight technology is a lot thinner on the older module than it is the newer one. Where our older LCD module uses a thin strip of electroluminescent display material, our new module has a very chunky diffuser in the back, which is coupled to red, green, and blue LEDs. This allows for a brighter backlight and the choice of backlight color in our new LCD module, but unfortunately at the cost of depth. To overcome this little hurdle, I started out by taking measurements of both LCD modules. After that, I started designing this little LCD adapter in Fusion 360 that would accommodate the different spacings for the mounting holes and the difference in depth. And finally, I 3D printed it. Now, unfortunately, the trouble with 3D printing things is that they don't always come out exactly the right size. Well, at least with my 3D printer. Though I think we can use this to our advantage in this case. You see, since the interior of all the holes and the cutout should be slightly smaller than measured, everything here should just be press fit, essentially. Yeah, that's pretty good. Our next issue to deal with is going to be the interference of the mounting holes with parts of the LCD's PCB. Totally fine if you avoid the traces. Might not even need the nuts since they thread into the adapter so well. Beautiful. Alright, one short heart attack later and we have the LCD installed. However, this is a completely different LCD than what I showed before. You see, I had the replacement all wired up, and even constructed this small board to control the RGB values of the backlight. However, when I plugged it into the Emulator II, it just didn't work right. First and foremost, I had installed the LCD module upside down. Secondly, the preset contrast determined by these two resistors on the board was horribly off, and I could barely read the display. And third, although the letters, numbers, and symbols on the display seemed to be pretty fine at first, they tended to change and flicker over time. And I think this might have been either a defect with the LCD module itself, or some sort of race condition / timing issue with the signals being fed to the LCD. Possibly a slight timing variation that I overlooked. So, not really having this LCD as an option anymore, and still having the older LCD around. It still works, by the way, it's just gonna go in my parts bin. I happened to find this LCD. Sure, it's a tad bit beat up, but it does seem to be pretty contemporary, somewhere around the 80s or 90s, and it's still one of those 1602 variants. It's pin compatible, the backlight works, and it's really easy to read. But yeah, this should make a far more legible display as compared to the original with the faulty backlight. Okay, let's see how this display's looking now. Yeah, that's pretty crisp. If you can even make that out. Seems like the auto exposure is kind of trash on this camera over here. Now, I'm gonna start putting this back together soon, but before I do, I've noticed a pretty interesting little problem. So the emulator should be reading off one or the other disk drive right now. Yeah, it's not working with the top one either. This freaked me out the first time I tried testing the LCD module. You see, off camera I had the other one in that was displaying the garbage on the screen, and then suddenly my disk drives weren't working. So yeah, I was convinced that I had done some sort of damage to the data bus in the digital side. Maybe killed one of the PIO chips or a buffer IC. But I mean, the rest of the data path seems to be fine. This seems to be going through a normal boot up procedure. So I had to poke around and... Yeah, it boots just fine. This here is the main power cable that sends power to the digital board, the analog board, and the floppy drives. And it looks like there might be a cracked solder joint somewhere in the connector, or perhaps just some corroded contacts. So before starting to reassemble this whole thing, I think we should take the power supply board out and see if we can touch up the connectors on the back. And of course, add some deoxit. Well, here are the power connectors right up here, and yep, they appear to be pretty cracked. Let's see if I can get a picture for you. Yeah, these look really bad, so I think it's our best bet to just reflow them with the soldering iron and add a little bit more solder. I think that'll do the trick. Oh, perfect. Can you all even read that? I might need to get some more cameras. Oh, and I guess that's what happens when you don't have a volume potentiometer connected. Infinite gain for your op amps or whatever. Okay, I've got the emulator set up here in a much better configuration, with the main chassis on a keyboard stand and the top resting on the table. Right now, the thing's working beautifully. We got the new LCD installed, the drives are no longer flaky, and there's no problem with any of the voice channels. Which means this is the perfect opportunity to mess everything up. Okay, we'll try to be careful here, but I think our next goal is going to be replacing one of these floppy drives with a Gotek floppy drive emulator. It's an emulator within an emulator. Now, this is definitely more of a modification than a repair. It's more of a quality of life factor. Hear me out, the floppy drives work great and all. Actually, I think these have been replaced at some point, so I'm not really sold on the whole longevity of floppy drives in this unit. I'd just like the ability to back up samples that I've recorded on the emulator to my computer, to easily archive the sample discs I have lying around without fear of the media degrading, and to perhaps find Emu II disk images online that I can easily throw onto a flash drive and get loaded onto the sampler. Basically, this is going to make the Emulator II a much more productive and reliable studio tool. And I guess we'll start out by removing this bottom floppy drive. Or I guess the entire cage first. Well, if this control chip's anything to go off of, this drive's from the 18th week of 1994. Which means these drives were probably swapped in around 10 years after this thing was made, if the 1985 chip codes in our emulator are anything to go off of. Though these drives could have been new old stock and swapped out later. Now we'll just install our Gotek emulator in the bottom here. By the way, the Gotek unit is just this piece right here. The rest was an STL I found online and then 3D printed. Now I do hear that they make 5¼ inch sized Gotek units, but I was going to use this smaller one for a different project, so I didn't end up buying one. I think my printer might have a bad habit of printing things slightly too small. And that should do it for the physical installation. Now, there is one little issue here, or maybe two depending on how you look at it. Spot the difference? Now, normally I'd use a cable like this to plug our floppy drives into a computer, or in this case the emulator. But in our case, the floppy cable for the emulator is like a mile long, or like 5.28 kilofeet for all you metric types out there. So yeah, I think I might try to get an adapter for... Wait a sec. You know, actually though, that's like shockingly close to working. I just need like a few more inches. I still got a bunch of these left over from the Game Boy project. Maybe right there? Got a normal 3.5-inch drive here, and the orientation for the notch is down. We'll see about right there. This might not actually be that easy. You see, pins 1 and 2 on the IDC connector are on the left-hand side of the 3.5-inch floppy drives. And you can see that pin 1 is usually indicated by a red wire on most floppy drive cables. Now, on our 5.25-inch drive, our pins start out on the right-hand side of the drive and move left. We have pin 1 on the top and pin 2 on the bottom here. So it looks like I'd have to get our cable to do one of these maneuvers. Maybe I'm just making a mountain out of a molehill. That's not actually all that hard. Yeah, this connector will just face in a different direction on the cable. It lines up. Yeah, there we go. I think I'd avoid going with the tomfoolery of the rubber mallet, and instead picking up a pair of these, or an actual vise. We now have the twist within the twist. If that ain't cursed, I don't know what is. Okay, we have our floppy drive and our GoTech wired up to the Emulator II. So let's switch it on and see what happens. Hey, look at that, it's reading. But there's something wrong here. Okay, so it successfully booted the OS off the flash drive. By the way, here's the website that I found the disk image at, and it's currently running OS version 3.1. I just had to make sure that the flash drive was formatted for FAT32 before putting the disk image on. But yeah, let's see what happens when we put a sample disk in. Okay, I'll select disk drive 1. And it loads the sample library just fine. Now let me load up disk 2 again. Yeah, not a huge fan of how the head just drags along the disk without it spinning. So, although this drive configuration technically works, it's pretty non-standard operation, and I don't really want to use it like that. Fortunately, I think I might have a solution that would give us proper drive operation, and even forego this custom cable. Last year, I got to go to the Vintage Computer Festival East up in New Jersey. It was a pretty fun time. I hung out with the System Source crowd, and I bumped into David from Usagi Electric, who's a pretty awesome human being, by the way. And I picked up this leading-edge PC clone. This case is never not hard to remove. So yeah, I took this thing home and installed one of these PicoMem cards and an empty ISA slot, and got to playing with some vintage DOS applications. But immediately one of the issues I ran into was the 2 floppy drives up front. After a bit of finagling, I think I got the 5.25 one working, but the 3.5 one still doesn't. But yeah, while taking this apart, I noticed something a little strange. Yeah, both these drives use a card edge connector rather than a card edge and an IDC. This led me to start taking this apart and see what was going on here. Plug that. It turns out this 3.5-inch drive has this neat little adapter board on the back. Yeah, it's just a simple card edge to IDC adapter with some jumper options. And it even does the signal crossover so that both of these notches line up. But yeah, I think a repair of this computer is going to have to take place sometime in the future. But in the meantime, I'm snatching this card and using it in the Emulator II. I might even have to dive into KiCad later and see if I can fab up a couple of these for the future. Alright, let's get rid of our custom cable. We'll use this Molex adapter cable to power the GoTech. Plug in our adapter card. Oh, that's close. Glad that extends out that far. Alright, we should be good to go. You can see it cycling the enable signal between the floppy drive and the GoTech, just checking if there's a disk in the drive. Plug in our USB. And we're loading the OS. Notice how it's not concurrently stepping this drive's head anymore. Okay, now let's try reading this disk. We'll pick drive 1. And the disk loads without a hitch. Now let's try reading off of drive 2 again. And cool, we're back to our null preset state, which means that we now have both drives functioning as intended. You know, I wonder what happens if I try copying this disk to the GoTech. Right, we'll select disk, copy disk. Okay. Oh, this is set up perfectly. We got the source disk in drive 1 and the destination, which is our GoTech, in drive 2. We'll hit enter. All right, it's reading the whole disk into memory. And we are writing to the GoTech. Oh, and we are overwriting our current disk image. Yeah, that's still the only file on there. You know what? Let's remove this disk and do a power cycle. Well, the image is valid. No way! No way! Wow, that actually worked! So it looks like we have a pretty good way of backing up disks now. We just need to make sure that we're creating a new blank HFE file on the computer and then loading it onto the flash drive. Not to overwrite the other disk images we have on there. Ooh, and I can even write protect the disks. I'll definitely have to make sure to do that. This is great. I think this GoTech might be the perfect solution for all my Emulator II disk drive needs. It allows me to both archive disks and use disks downloaded from the internet. Originally, I was thinking about using the spare drive here with a grease weasel in order to archive all my Emulator II disks, but it looks like I won't have to go through that tedium anymore. I'll just rely on the GoTech. And there we have it. I think that concludes all the restoration and modification work that I'm going to do to this Emulator 2 for now. So I think it's time to put this thing back together. Well, last time around we put the Emulator 2 back together, and I shipped it off to a recording session. Also, my lav mic broke, so please bear with the terrible camera audio for the next few minutes. It worked fantastically throughout the entire session, and I didn't have any issues with it then. However, when it came time for me to demo the synth for the rest of the video, I noticed a little bit of flakiness in that voice channel number 7 over there. And shortly after, channel 7 cut out completely. So the synth ended up in pieces back on the bench, and after doing a bit of feeling around on the circuit board, I noticed one of the chips was surprisingly hot. Unfortunately, it was one of the AMI filter chips. That's borderline unobtainium, or rather, overpriced. After about a month of searching around online, I was able to find these. A little new old stock cache of the S3528 filter chips. Let's just open this here. And there's our new old stock 80s filter chips. So it should just be a matter of taking out our digitally programmable low-pass filter chip from channel 7 and swapping it out with the new old stock part. Okay, I'll now power up the synth. We'll go into the Special Functions menu, select option 12, and turn all the channels off but 7. There.
Baby, baby, baby.
Little James Brown sample there. Oh, that still doesn't sound quite right.
1, 2, 3.
It's pretty crunchy. Let's try it on a different channel.
One, two, three.
Alright, it looks like we'll have to do a little bit more troubleshooting here. And having built a handful of 8-bit samplers in my day, I can already tell what the problem is. We lost a bit. Let me elaborate. Here we have a very simple 8-bit sample player. I've recorded a short sample, exported it as an 8-bit unsigned raw PCM file at 16 kHz, and burnt this raw data onto this 32K EEPROM. All the data bits, which are these yellow wires here, are fed into this orange R2R DAC, which is a basic resistor ladder. And all the address lines, which are these blue and white wires, are fed by these cascading 74HC4040 12-bit counters. Now to trigger the sample, I've got a button and an SR latch that resets when these counters hit a certain value towards the end of the sample. And that SR latch feeds into this AND gate right here, which, depending on the state, allows this clock signal from a function generator off camera to pass into these cascading counters. This clock signal allows the counters to, well, count when active. Altogether, here's what this circuit does. Hello. Now, on the Emulator II, you notice how we have sort of a crackly, staticky kind of effect on our sample? Well, this is indicative of a data line to the DAC being disconnected. Here, let me show you. Hello. See, with one of the bits missing, it gets kind of grainy like in the emulator. Circuits like these are really fun to play around with and are great introductions to digital audio, so let me know in the comments if you'd like to see more videos on audio circuit design like this. Alright, tracing back the signal path here, we have our output, which is channel 7, which is being fed from this SSM 2045. It's a combination analog VCF and VCA filter IC. Looks like this S3528 is doing some sort of signal processing in parallel. So the signal's bouncing back and forth between these two chips. The signal interacts with this TLO84 op amp in this 3202 IC and is fed by this AM6072 digital to analog converter. So before we break out the scope here and see if we're missing any of the data signals to this chip.
1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3.
There we go. That was way easier than I thought. Alright, so a bit of a crusty socket on the digital to analog converter here. So let's do our due diligence and clean it out. I've just applied a little deoxit there, so now it's time to reseed the chip. And power on. We'll just do our little song and dance to get into the channel selection menu and disable all but channel 7.
1, 2, 3. Baby, baby, baby.
And yeah, that seems to be good. Okay, so the deoxit solution didn't sit particularly well with me. The digital to analog converter felt like it hadn't really moved since it was installed in the factory, so in theory the pin should have been making pretty good contact with the socket. So, just to be sure, I took the analog board out of the synthesizer just to see if I could find any broken traces or any other problems. And boy did I. Taking a look around back here, we have our digital to analog converter IC. And although it's a bit hard to see from this angle, the solder joints look a little bit dull and cold. But also, I noticed flux in this area and this area. You can see on the other side where they bodged in a capacitor across this resistor. So I cleaned off the surrounding area, and here's what I found. You see this trace right here? Well, it seems to connect fine right where the solder mask is removed, and doesn't interfere with this connection over here. However, it never makes it to this point here. Luckily, the circuit design for each individual channel seems to be constructed in a straight line, and then pretty much copied and pasted across the board. So, looking at an identical layout for channel 5, you can see the circuit is supposed to be connected. So in order to remedy this, I'll add a bodge wire from here to here. and reflow the connection points for our digital to analog converter, just for peace of mind. Okay, did we fix it for real this time?
1, 2, 3. Baby, baby, baby.
Okay, awesome. Let's put this thing back together now. And there we have it. That concludes the repair segment for this part of the video. Took long enough. So, going back to our list here, did we fix the bad voice on channel number 7? Heck yeah, we did! Eventually. Flaky floppy drives? Thing of the past. We even got the GoTech replacement in. Low C replacement? Low C replaced. We even got ourselves a new, well, different LCD screen. General cleaning. Yeah. Sure. And for computers, well, we'll get to that in a few, so I'll cross it off the list for now. Which means this Emulator 2 is in tip-top shape and ready to go. So let's do a few demos and show how the Emulator 2 can be used as a musical instrument rather than an electronics repair project. Alright, so the Emulator 2 was used in a whole bunch of ways over the years. And I think first and foremost, as a preset synth. And yeah, it's kinda nuts. You got all this power in front of you and you're using it as a glorified rompler, really? But yeah, let's take a look at some of the sample discs this came with and see why this might have been the case for a lot of keyboardists. Alright, we're booting into the null preset section with the Emulator 2 boot disk here. Got a memory test in case your RAM goes bad. An update release to version 3.1 of the OS. And let's take a good use case for the Emulator 2 to be a good preset synth in general. The grand piano. Right, we're gonna go to the disk menu. Uh-oh. We got one of the many errors of the Emulator 2 right here. Software version 2.3, when we boot it up with 3.1. There we go. Alright, booting off of disk 1 here. Taking its time. And here we have the piano. I guess the previous owner had this defaulted to preset 16. So we'll just key in preset 01. And there we have it, our grand piano preset. Now in 1984, I don't think there was another synth that could do this, other than something like the Fairlight CMI. So at this price point, this was pretty incredible. And yeah, it sounds like piano in a can, but I think in a mix you wouldn't really be able to tell. Let's see, any other piano presets in here? Sounds pretty similar, but with the dynamics tweaked a little bit. Oh yeah, by the way, this thing's velocity sensitive. Piano 3. I like this one, it's a little softer. Ooh. Woof. A little bit of a attack on there, okay. Piano arpeggio. Pretty cool. Chorus piano. Koto piano. But yeah, you get the picture for the whole piano thing. Let's try orchestra tune. That's so cool. Let me take a look at something here. Get a preset definition. And then I think it's 1.7? Yeah, they got like 3 orchestra tune voices in here. That's a neat preset. What else we got here? Digital synth. While we're at it, let's see how long it takes to load a disk. So, come here often? Alright, like 40 seconds? Digital synth, eh? Okay. Oh, that's a very FM brass. Okay. Yeah, sure. It's utilizing those SSM filter chips. Nice. Cool. And it's got dynamic range as well. I think not. It's got more of a clav sound. Same. Gross. Hate this. Nope. Bad sound. Okay, so in my opinion, this is one of the pitfalls of early digital synthesis. There's a bunch of really good sounds and a whole lot of really bad sounds. And whatever synth they were sampling for this disc just wasn't up to snuff. Here we have acoustic guitar. It's a pretty good guitar sample. Next up is voices. It's like something out of Explorers. You know where else you might recognize this preset from? Alan Wilder really got the run for his money on that one. I've needed is you in my arms. Let's try this bass synth. What's the deal with airline food? Ooh. why buy an Oberheim? Yeah. Okay, so maybe the emulator isn't totally fixed. Now the control panel right over the display is pretty warm, so my theory is we might be driving the backlight a little too hard, and it's causing the chips on the LCD module to overheat. The problem seems to go away if you let the emulator cool down for like 5 minutes, or if it's constantly running. This doesn't happen. It's only on the restarts. Which I guess is why this LCD module ended up in my junk drawer anyway. But nope, not gonna fix it. I've been working on this thing for 6 months, and I'm not gonna open it up again anytime soon. Now, let's move on to the main attract of this synthesizer, which is its sampling capability. I want a nice pad sound and a nice soft lead, so I think the most apt synthesizer for the task is the Omnichord. Alright, we got our null preset. And we'll sample, and we'll sample. There we go. Okay, so we'll turn the keyboards and chords all the way down. Have the sonic strings up. There we go. See if we can boost the gain a little bit. Hell yeah. Yeah, no. We'll set our sample length for 4 seconds. Let's define our voice. All right, we're in the key of C, so we'll do C here, our low C, and our high C. Yes, this will be new voice V01. So let's raise the threshold of the sample. See on the bottom here we have our VU meter. And this dash up top is how loud of a threshold our sample has to be to start recording into the emulator. Since when you sample into the emulator, it does it automatically based off a certain volume threshold. Yeah, that seems good. All right, we'll arm it. You know, let's actually do 2 samples here. We'll do a low section and a high section. Okay, so let's do a sample in at G. Gotta go to preset definition, and we have our voice already loaded, but we don't want to use that voice anymore. So let's first deassign it from the keyboard. Enter. And now let's erase that voice. These double triggers. The lack of... Come on! Come on! You see, it thinks I'm pressing 11 here, and that's because there's no debounce circuitry in the keyboard. So you have to be very, like, precise. Yeah, okay, there we go. Alright, sample. Hey, I'm sampling here. Alright, define voice, and this is a G. Alright, so we got like 1 octave of G going on here, and it's going to be the lower octave. Oh, the gain set. Wait, threshold. Oh, or threshold was reset. There we go. There's our sample. And we'll do another one. We'll go down to right before the previous sample, and our high key will be the C. You know what? I'm still not happy. We'll go back to the C's. We'll do 3 C samples. You know what? I'm going to do a really easy clear just by loading a blank disk, because I think I want more high end. 2, define voice. Do an octave of C as new voice 1. Bump up our threshold here and arm it. Actually, I think I'm going to do it in fifths. And then 1 more. Alright, we got our samples in for the top section of the keyboard, so now let's focus on the bottom. And for this I'll do a C major drone. The lower key, and our high will be this B. And we'll hit 9 to force the sample. Alright, it's a good starting point. Alright, so now that we have all of our voices laid out, let's name this preset. I'm going to select 31, copy preset 1. Now get ready for some tedium. Alright, cool, we got our preset. Now let's tweak it a bit. Let's start out with the chords down at the bottom. And first, let's see if we can loop it. Add additional voices? No, thank you. All right. So it just kind of ends there. Alright, now it should go on indefinitely. Let's control our voltage controlled amplifier. Let's give it some attack. A little decay as well. Woo! That sounded good. Alright, now we're over in the filter section, and let's give it a little low pass roll off. Let's give it a bit of an envelope here. And let's change around the filter envelope. So let's match this up to the VCA. Actually, I don't really want an envelope on the filter, but maybe an LFO. So, go to option 2. All right. Oh. Let's go over to the LFO section and turn it way down in frequency. We gotta change that. Alright, let's change the VCA over here. Come on. There we go. We'll change the current voice. Yes. Nope. Voice 2. Voice 3. Voice 4. Want a longer release on this, so we'll do and maybe a little bit of filter as well. You can hear right there where the sample loops around and clips. Now, let's try to fix that, but instead of using the controls on the Emulator II, let's set up our Macintosh here. And while I do this, let's have Future John explain how this whole setup works. In order to get your Macintosh talking to your Emulator II, what you'll need at the bare minimum is a Macintosh serial cable, a DB25 male connector, and a blue SCSI hard drive emulator. First, I went ahead and created the Macintosh to Emulator II serial cable. This was done by purchasing a standard Macintosh Mini DIN 8 serial cable and heading over to SynthArc's Emulator II archive for the pinout. Now, here's just a basic visual diagram of how the cable should be wired up, since I've seen on the internet a lot of incorrect pinouts for these Mini DIN 8 plugs. Once that's completed, let's take a look at putting our required software onto a disk image, which will be loaded onto our blue SCSI. Alright, so what's it gonna take to get Sound Designer on your classic Mac? First we're gonna go to the blue SCSI page, then to their Start Here link, and to their Images tab. Next we're gonna go to their collection of blanks pre-made and bootstrapped images. I'll go to pre-installed macOS images, download HD0 Open Retro SCSI 7.0.1, and also go into their macOS 8.1 folder, and download that. While I'm at it, I'll go over to Macintosh Garden, find a copy of Stuffit Expander, and yeah, we'll go with this 5.5 image file. We'll also search for Sound Designer here, and get the version that has Sound Designer 1.5 and the version for the Emulator II. Now, in addition to all this, I also have Basilisk 2, which is a Macintosh emulation software installed on my computer. In this little disk folder here, I'll throw in the .sit file for Sound Designer, the later System 7.5.3/8.1 disk image, and the 7.0.1 disk image. This disk image here is going to be the one that will run on our Macintosh. Oh yeah, also I'm going to copy over Stuffit Expander. Now when I run the Basilisk GUI, let's take a look at some of the setup here. I'm emulating a Quadra 900 with a 68040 microprocessor, and I've also got the Quadra 900 ROM kicking around in the Basilisk 2 ROM folder. As for this Volumes tab, I have Enable My Computer enabled, so that this emulator can access my desktop's file system. Next, I'll add my volumes. In our disk folder, we'll first go with this HD10 file. This is the volume that the emulator will boot off of. Then we'll be adding our disk image that we'll put on our Mac. And that should be it. I think we can start now. That was loud. On our virtual desktop here, we have our Mac HD volume, which is what the virtual machine booted off of. We have this PC, which is the file system for the host computer, and our Open Retro SCSI disk image that'll go on the Macintosh. Alright, so now navigating our PC's file system, we're in our Basilisk 2 folder, and let's install Stuffit Expander. Awesome. Can we download the disk image version? Throw that into Basilisk. Oh, yes we can. Note to everyone out there, download the .dsk file, not the .img. Alright, we're just installing Stuffit Expander here. And it was successful. Now we'll open our Retro SCSI volume and drag our Sound Designer SIT file over to it. Now we'll just double click, and we've extracted Sound Designer onto the Open Retro SCSI volume. Now we can close out a Basilisk 2. Next, let's mount a micro SD card. This is a 16GB card, formatted as exFAT, and we should just be able to drag our open retro SCSI image over here, and wait a while, and now we can insert it into our blue SCSI. From there, we plug our serial cable into one of the two serial ports, which you'll be able to select in the Emulator II software, and our blue SCSI gets plugged right into the SCSI port. And look at that, it's mounted. Now all you have to do is click on the Open Retro SCSI hard disk icon, open the Sound Designer folder, and click on Sound Designer E2. Finally, if you're nuts like me, you can wire up a VGA port to the back of your Macintosh. All I had to do was solder these points into the analog board. That then breaks out into this little connector box back here, and goes into this open source scan converter. Unfortunately, this isn't true VGA that comes out of here. It's some sort of Macintosh proprietary video signal, so this is going to be a necessary step. Side note, the connector box contains an inverter chip, since the Macintosh video signal is inverted from the VGA signal. Then, after fooling around with all the settings on the open source scan converter, just to make everything look right, it gets pumped into this HDMI video capture card, which is then USB into the computer. And since the Macintosh is black and white only, we just mess with the settings inside our video editor. And now back to the demo, where I think the audio interface stops working for a bit. Thanks, future me, for explaining how this whole setup works. So without further ado, let's get into some sample editing via the Macintosh. Power on our emulator here, and we have our OmniPad preset loaded back in. Now we'll just switch on the Mac over here. And here we have our Sound Designer 2E software. Now the first thing we're going to want to do is load our samples in. So we can go over here to File, and then E2 to Mac. Then we get this error message here. It's because the emulator tries to load some of the software off of disk 1 first, but this is a little too slow for the Macintosh's liking and causes a timeout in the software. So yeah, if you had your software in disk 1, it would pop up immediately. We just gotta try again. You can also see here that the Emulator 2 is now under the control of the Macintosh. So let's start out with our new voice 1, load it into this Omnichord patch file folder, and I'll rename it Sonic Strings 1. I think I'm gonna end up actually just loading all the voices in at this point. And this one is our C major chord. And alright, that's all our samples loaded into the Mac. So let's go through some of the features right here on the left-hand side. First, we have this sine wave icon over here. Basically, it creates a sample from scratch. It generates a Car+Strong waveform, which is kind of like a plucked string sound. I think it's the same algorithm that's used in the OP1 string synth section, so there you go. Next we have this box over here. This is our zoom functionality. The window down here allows us to resize the waveform in both the amplitude and time domains. Next we have the option to turn graduals, gradients, the marker lines, on and off. Next we have our highlight tool, which allows us to select different parts of the waveform to copy, paste, edit, delete. Over here we have our mixer, and this adds additional functionality that I don't think you'd be able to get out of the Emulator 2 alone. Functions like mix and merge are actually pretty straightforward in the Emulator 2, but something as simple as gain change is a bit of a difficulty. I haven't really found a way to increase the amplitude of a recorded sample in the emulator, only the ability to attenuate. So that's super helpful. You got things like peak and shelf EQ, which is actually a pretty impressive feat for the Macintosh. It's doing active digital signal processing right here, which is way more involved than just being a fancy interface that takes the place of the front panel. Next up, we have this editing tool, which I can't click. Maybe if I zoom in. Ah, there we go. This is how you go about editing the voice on a sample point basis. It's kind of like the drawing tool in Audacity, if anyone's ever used that for sample looping. Next up, we have the preview or quick transfer button. Don't use this one. Well, at least for this context. Basically what this does is take your sample as it's been edited here and plops it right in the middle of the keyboard. Which is all fine and dandy if you're working on a sample that you just loaded into the emulator. I mean, this is kind of the default space that the sample falls into when you hit record. But with the way our samples are currently spread out all over the keyboard, hitting that button would just mess everything up. I'll show you the workaround in a bit. Next, we have our listen to function, which just plays the sample right out of the Macintosh's speaker. Here we have our loop sustain markers, and that allows you to place them right in the sample where you want it to loop over and over again when you hold down the key. And then loop release, which allows the synthesizer to pick a different part of the sample and play that on loop as soon as you release the note, which is a pretty cool feature. Yeah, we'll just put those back. This button here puts a line at the 0 point of our sample, which is pretty useful if you're trying to loop right at the 0 point crossovers of the wave. These guys here are just little notation points, and I'm not sure what this one does. It looks like it just gives you information about the sample at different points in the waveform. Here in the display menu, we can draw our waveform again, and draw our waveform again. I think both these buttons do the exact same thing. Calibrate's kind of neat because we can configure serial port, scale markers, the volume of the Mac speaker, and our frequency plot. Change that to log and make that 20. So yeah, there you go. I guess you can use this to see the different harmonics at the different points in the frequency spectrum. Might be useful if you want to do some sort of EQing or filtering. The MIDI keyboard's kind of a neat feature. You can play the synth from your Macintosh. You can even record something in and play it back. And something really useful here is the loop window. So yeah, looking at the two loop points I placed right here, you can see that they don't quite line up. So if you want, you can just scoot the loop point of your sample over until it does. Which is way more forgiving than using the sliders on here. Since each voice contains thousands or tens of thousands of individual sample points, using the sliders gets kind of tedious when you're trying to fine-tune in the loop point of a sample. So it's really nice having this graphical functionality over here. Now, the main problem I have with this patch is I find the sonic strings portion a little too quiet. So what I'll do there is go into the mixer and do a little gain change. I'll hit normalize and then execute. Get out of that. Whoa, okay. Yeah, look how much bigger our sample is now. Now normally if this was the only sample loaded into the emulator, I'd hit this button over here. but since I want to avoid overwriting the sample definitions for our C major chord down here, and this portion up here for the sonic strings, I'll just instead go to Mac to E2, select our Sonic Strings 1 sample, which is this one that we just edited, and then replace new voice 1 with our Sonic Strings 1 sample. This just changes the audio data within the voice, the actual thing that we sampled in, rather than any of the attributes about the voice, like the filter settings or where it is on the keyboard. Now, see how much louder this is than all the other string samples? Let's do the same to the rest of the sonic string samples now. All right, and that should do it. All right, what else can we do here? Oh yeah, this next one's a godsend. The E2 front panel. Look at that. Now, not all of these options work. Like, you can't be clicking into the sequencer here. In fact, if you'd prefer a drop-down menu of all the functionality, you can go up here to Module and change all these aspects. Over here we have the preset definition. So this allows us to select the different presets that are in the emulator. There's only one at the moment. And change things like the name of the preset, the arpeggiator mode, and the MIDI mode. It also shows us how much sample memory we have left if we want to record anything else into the emulator. Here we have our voice definition. And this gives us all the different attributes of the different voices. Now, one thing to note here is when you get to the voice that you want to select, you have to hit Look up here. And that'll update all the information preloaded onto the screen. So, for example, if we wanted to choose Sonic Strings 4 here, we could do things like put it in solo mode, which is just monophonic. We could play the sample backwards. And we can loop it. Do a forward and back loop. Now, the reason why the loop keeps looping is because the envelope is just set to all the way up at full. Let me see if I can pull that up here. Yeah, you see how that release is infinite? If we had it down to like 5 seconds and went back to the loop menu. See, one thing we haven't gone into yet is the filter menu. All right, here we have the ADSR section for our filter. Its preset voltage control parameters, LFO amount. I've just got a little bit in to give it a bit of a waviness. And you can control keyboard tracking here. All right, what else we got in here? We have our real-time control. This just maps the mod wheels and the foot switch inputs to different parts of the synth, as well as increased MIDI functionality. And underneath our special menu, we can see the allocation of our voices. All right, and we have Sonic Strings 1 right over here. And if I click that, you can see here we have the root note, and this is how far down the sample extends. All right, so that was the other mode of Sound Designer, the front panel display. Now, let's just go back to the waveform and take a look at our C major chord here. Now let me just click into the loop window and align these a little bit better. Back to E2, our C major chord. Huh. Interesting. I see what's happening here. Okay, all right. Yeah. Oh, that's fascinating. Wow. All right, let's move our sample points in a little, okay? What I think's happening here is technically our loop point is like outside the scope of the entire sample. So we've kind of broken out of the sample space and gone through the rest of the emulator's memory, which is why you hear the garbled noise, and then the first sample we loaded, second, third, fourth, plays to the one we were working on, goes back through it. That's interesting. That's a fun bug. All right, moved our sample points in, which are just gonna be like jump points, pointers. All right, let's try a few things. We'll try smoothing, crossfade looping. If our sample's this long, and we set our loop points here, this allows us to crossfade the sample. When it gets to the end, it'll start playing a little bit of before the beginning of our loop point of the sample and kind of crossfade it into the loop and play it normal and then start to crossfade it the other way. So. Alright, now let's boost the gain. You remember how it was like peaking when we were trying to record it into the emulator, but now it's not doing that? We can always go back into the settings and attenuate it, which is nice. So basically how they have this set up, I'm just now realizing that everything I tried to record from the Emulator II over the past 3 hours never went through the audio interface over there. Damn. All right, here we are in the music studio. Currently, we're in the middle of July, so it's too hot for sweaters. At this point, I'm like 7 months into filming this video, so wardrobe consistency, yeah, it's gone out the window. But yeah, we have our Emulator II all set up here. So I think it's about time we do a proper recording of that omnichord preset. And there we have it. I hope that's a pretty good demo in lieu of the audio capture not working earlier. So let's continue on with the video. Thank you, Future John. Now, without further ado, let's take a look at a tried and true staple of modern day music production. Plunderphonics. Or sampling, as we call it now. Alright, we'll go to the sample menu. Some 90s soul revival should do the trick. Sample is good. Let's listen to what we got here. Okay, I'll also define the voice here. Next I'll go to the preset definition and name our voice. Just want to name the voice. Just want to name it. That's it. Just want to name the voice. Come on. There we go. Alright, now that we got our naming all set up, let's loop it. Alright, now we're going to voice definition, and we're gonna truncate the start of the sample. See, we can shave off a little bit there. And now also in the voice definition menu, we'll start the loop. Alright, so from here on out, I could just go through the voice definition menu and operate the different menu items using the sliders. I could truncate the sample, which is just chopping off bits from the beginning or end, or I could modify the loop parameters, so have it start at different points in the sample and loop over and over. And yeah, while you can do this from the front panel of the synthesizer, it gets pretty tedious. Once you start using the sliders, you'll notice a bit of a delay when you're entering data into the menu items. The common parlance being this is a coarse adjustment and this is a fine adjustment. But with literally hundreds of thousands of sample points within your sample, this whole process becomes extremely tedious and a bit finicky. So I find it best to use the Macintosh for something like this. Alright, next we'll copy all our data over to the Mac. And of course it errors out, so we'll have to do it again. There we go. Save this new voice as HL1. Yeah, this is our sample right here. Alright, let's start our loop from the beginning. Takes 4 samples from the beginning. Okay. So our loop starts from 4 sample points from the beginning, like the dialogue said. And then let's see where it ends. Ba-da-ba-da-bam. This would be about here. And let's send this data back to the emulator. You see, we're close. Let's move the sample point back a little. Send that over. Give it a listen. You might want to move it back just a tad. Update that. See how much easier this process is? It's still a little bit off there, so send it over like that. So unfortunately, it takes about 5 or 10 seconds for the whole sample to be sent back over to the emulator while you're doing your looping process. And this is a bit of an inefficiency on the software's part here. Now, Sound Designer doesn't really track any edits that you do on the synthesizer itself. It only cares about the sample data that it has loaded into RAM. So once you're done with your edit, even if it's just changing a really simple data point like your sample loop, you'll send it all back over to the Emulator II. because it assumes, and probably rightfully so, that you've done more than just edit one point of data. Regardless, let's turn our attention back to the Emulator II for a bit of fine adjustment. Going back into the voice definition, we'll play the current key that our sample's in. It's the only voice we're working with, and we can take a look at our loop points. You see, I hear a bit of a stutter there, so I'm going to try to move the loop point of the sample a little bit further into it. I'm like almost there. Yeah, I think that's it. Yeah. I'm loving the way that's sounding. That's real good. See, this is a pretty neat option. It's like, if you're not using the rest of the sample, do you want to truncate it? I'm going to leave it no for now because this is the only sample that I'm going to be putting in the Emulator II right now. Alright, now let's do a little bit of lead into the sample. Actually, you know what? Go into the mix, a little gain change, normalize. And so now we've just boosted the gain to the maximum amount. And let's now change the parameters of our preset. And there you have it. That's digging through the crates with the Emulator II. Alright, now that we've fixed up and have extensively demoed the Emulator II, let's do a bit of a wrap-up and review session. Who is the Emulator II for? Well, according to my extensive notes on the subject, masochists. Oh. Now, let's go over some of the pros and cons of owning an Emulator II. First up, in the pros section, this thing sounds undeniably great. I think that the digital sampling section, with the companion circuitry alone, gives a surprising clarity and punchiness to the samples. And with the added benefit of running everything through those lush-sounding SSM filter chips, I think it gives the synth a character of its own. Am I describing wine or a synthesizer here? But in all seriousness, this is just a really good sounding piece of gear in general. Next, the workflow is interesting. While the whole process of creating a patch can be both time-consuming and limiting, once you get your sample into the Emulator II, it really starts to show off its capabilities. You can get really into the weeds with the whole digital signal processing aspects of the Emulator II, and that's not even including the built-in sequencer and all the MIDI functionality. So, once you get a good workflow going, the whole user interface just kinda sucks you in and makes you really want to play with the samples. Now, the Emulator II can also be a very versatile studio tool. You can use it to play back samples, you can make your own samples, you can make your own sequences, and in some cases you can use it pretty much as an effects processor. Plus, you can use this in just about any genre of music you could think of, from R&B to classical to electronica to rock. Finally, this thing's just fun to play with. If you have the attention span and a few hours of free time, you can have a lot of fun with this thing. Plus, the keys and the mod wheels are just pretty good quality in general. Alright, that was the pros, now on with the cons. Cost. I don't know if you've been on Reverb or eBay lately, but oh my god, the price on these. Back at the start of 2025 when I bought this, it was $4 grand and it showed up at my doorstep broken. I was not happy. I did get some money back for it, but regardless, that's a lot. Aside from the high cost, this thing's unreliable. And no, I don't just mean from a hardware perspective, the software is also buggy, even in its final release. I think most of the software bugs stem from a lack of compatibility between the different software versions. Sometimes an OS mismatch throws the entire menu section for a loop, especially when you're loading samples off of a disk with OS version 2, but you've booted the emulator off of a OS version 3 disk, and vice versa. since the different menus as UI elements are stored on the floppy disks rather than in memory. This can cause some confusion when you're doing some disk swapping. And that's the majority of the software bugs I've had. You go to select a menu, it loads off a different version of the disk, and it gets confused. But aside from that, sometimes there are just glitches. I see most of these obscure errors as memory errors. Like when you want to loop sample 3 here, sometimes it's normal, but then sometimes the endpoint mysteriously vanishes, and then you start running through the other samples and program memory in the emulator. I've also occasionally seen this when trying to transfer a sample to the Macintosh and it just doesn't know how long the sample is. And for my last rant on this topic, the whole sound designer thing with not being able to load your parameters first try if you're booting off disk 2, but that's kind of a minor inconvenience and more of a problem with the sound designer side of things, I think. Anyway, moving on from there. The thing's complicated. I mean, the thing's got 2 Z80 CPUs, a microcontroller, a whole bunch of RAM, and most of the filter section of an 8-voice analog polysynth all wrapped up in one. And let's not forget the weird telephony filter chips that took so long to find, and weren't too cheap either. I don't even know what I'd do if the microcontroller died. Next up, can we talk about the buttons? I've been dying to talk about the buttons. Oh, they're bad. Like, really bad. Some are way too sensitive. Others, not sensitive at all. I think this boils down to cheap buttons that have oxidized over time and a lack of debounce circuitry. But yeah, these buttons suck to use, and I'm so glad we got Sound Designer working because its Emulator II front panel emulation is choice. Also, it seems these sliders scale really weird. They almost have a velocity to them as well, and I think that brings me on to my next point. Slow hardware. Yeah, the thing that really kills the Emulator II for me is just how long it takes between each operation. It takes almost a minute to load one patch, and about 5 to 10 seconds for each of these menu blocks, which really puts a damper on things if you want to change a setting over here and then change one over here real quick. But once again, I think Sound Designer relieves us of a lot of these front panel issues. It doesn't have to load each section from disk every time. And once you've transferred your patch to the RAM, it's not a huge deal. But in short, the disk drive will always be the most sluggish experience in the known history of synthesis. Finally, you can't gig with it. Once this goes in my studio, it's never going to move. Ever again. It's old and fragile. Yeah. So you want an Emulator II, but don't want to shell out the money or time, repair costs, terrible button. What are your options? If you want a crunchy 80s sampler, get something like a Casio SK10 or a Casio SK1. If you want a much better sampler, I'd take a look at Akai's MPC series. Let's see, I hear Arturia makes a pretty good Emulator II VST. Or if you just want a sampler, go ahead and use Edison and FL Studio. So in the end, who is the Emulator II really for? Well, obviously gearheads and synth collectors. I mean, come on, your collection's not complete without the Emulator II. I think that people that like to tinker and fool around with things would fall in love with the Emulator II. I mean, if you have the patience and are willing to put up with the emulator's quirks and archaic isms, sure, you'd have a field day. Oddly enough, retro computer enthusiasts, especially if you have an old Macintosh lying around that you're dying to connect up to this thing. Plus, it scratches that itch of using old media, and if you're the type, backing it up. So yeah, a little data archival in there. And finally, if you like a challenge, the Emulator II is your synth. It will fight you tooth and nail every step of the way. But hopefully, with enough patience and determination, you can get magic out of this thing. In short, do I recommend? Hell no! Stay far away from this thing. Just use a VST or something. However, if you're willing to cough up the cash and take the plunge, I wish you the best. You'll need it. Hey, thanks for watching. If you like this video, go hit the like button. And to see more videos on old technology, hit subscribe. I'll see you in the next one.